Welcome to myprojectbazaar.com. Our project title is Generating Correlated Digital Certificates Framework and Applications. Abstract. Bolstering public key authentication of network entities, digital certificates are an entrenched part of Internet security. A digital certificate is an electronic document signed by a certificate authority, vouching that the identified subject owns the declared public key and the corresponding private key. In general, CA are also responsible for certificate revocation as well as reissue, and certificates by nature are considered independent of each other. In this paper, we address the problem of certificate management and propose a flexible framework to create correlated certificates. We then apply it to implement the so-called multi-certificate public key infrastructure, which support user self-service such as a certificate spontaneous substitution as well as self-reuse after self-revocation. To the best of our knowledge, this is the first scheme for certificate users to achieve self-reissue. Another application of the proposed framework is the so-called anonymous digital certificate, which still binds a user identity to her public key, but in an anonymous yet user controllable manner. That is, a user can reveal her identity key binding only to her specified communication peers while remaining anonymous to the general public, achieving privacy as these certificates are generally unlinkable. Let us see the proof of our project. First, network deployment is done. In our project is taken as infrastructureless network, so we have to implement ad hoc wireless network. So in that, random waypoint model is implemented for mobility, and we have to implement our PCMKI architecture. In that, we have to calculate the RSA model as well as the digital certificates for digital revocations. There is certificate revocations and avoiding the certificate reissues problem. And in RSA model, we have to generate the pair of keys, that is private and public keys. If the keys are generated, then we have to implement the certificate digital certificate, that is multiple digital certificates using one-way hash function, and from that data transmission is done using these RSA and digital certificates. We have to use TCP connection for successful data transmission, and performance evaluation is done by using packet delivery ratio, throughput and delay. Let us see the output of our project. First, open the VMware workstation. In that, for running the project, we have to open this terminal window. It is in bottom of the VMware workstation. Click this terminal window and go to that our project folder. For running our project, we have to type ns main.tcl. This is syntax for running our main file. Our process is producing private and public key pairs, and that is RSA model and one-way hash function, that is for our digital certificate. This is printed in this terminal window. This is for one-way hash function. This security is provided for one-way hash function, that is digital certificate, and the routing informations are printed. It will display one output window, that is called a network animator window. Our network contains 15 number of nodes. When we start this play forward button, it will start for working. This is for increasing or decreasing the speed. So our 15 nodes are formed in random manner. So now private and public key for all nodes is set, and if we are sending any information to the destination, in that path only it sets the RSA the key for that node and sends the information via that node. So that path is only valid key and other nodes have invalid keys. It is printed in this place, as well as this nodes information, that is nodes label. So now all node have keys, and if now transmission is done, so in that place only transmission node have that key, so all other nodes remains idle. So only these keys are valid, so that is printed in this place as well as this nodes label. So all other keys are invalid. In our project, source node is 0 and destination node is 4. For analyze the performance of our project, type GNU plot space thr.plot for throughput. We calculate our throughput using Mbps megabits per second. In existing system, they achieve less throughput compared to the proposed system.